Hi students, this is Mrs. Turner, and we're going to start a new chapter, which is all about parallel and perpendicular lines. So this first section is just going to introduce us to what parallel and perpendicular lines are. We're also going to take a look at what are called skew lines, and we're also going to take a look at what's called a transversal, and all the different types of angles that are created when you have these intersecting lines. So on your notes, we start off with 4 terms here. With any video, don't forget you can always pause if it's ever going too fast. If you need to just take some time to write some things down, you can always rewind so that you can listen to something again. But I do recommend, take advantage of that pause button. So if you want to pause and just copy everything down that you see here and then hit play and then just sit back and really listen and kind of watch as I go through each different term here. Okay, so the first definition is for parallel lines, and parallel lines are coplanar and they do not intersect. So if we take a look at our diagram, okay, we have this cube here, and you can think of every side as a plane. So there's different planes on here. And if we look at the top side, so if we look at this top of the cube as being a plane, then line AB and line EF would be one example of parallel lines. So they're on the same plane and they're never going to intersect. And the other way that we can see that from the diagram is with the symbol here for parallel lines, which looks like 2 little arrows or greater than symbol. Okay, so just like we did with congruent segments when you matched up single tick marks, double tick marks, triple tick marks, right? Those were markings to indicate that segments were congruent. Well, it's kind of the same idea, but now you're looking for these little arrows that indicate that the lines are parallel, okay? And then how we name that is written in your definition there for you. So line AB is parallel to line EF. So notice this symbol here in the middle for parallel. It's just 2 parallel lines, kind of looks like maybe the number 11. All right, and then if you remember, we name lines by 2 points and the line symbol above it. Okay, so that's one example of parallel lines. There's another example on here. So we've got line EG is parallel to line FH. Okay, it's a separate set of parallel lines. Now we're looking on this front side or this front plane, and they are, think of it as like they're going in the same direction. They're never going to intersect. And you can see the symbol there on those 2 lines are those double arrows. So that's indicating that those are a separate set of parallel lines. Okay, and again, we can name it or state that using the names of the lines. So line EG is parallel to line FH. Okay, so those are parallel lines. Perpendicular lines are now 2 lines that intersect at 90-degree angles. So I'm going to kind of clear off my diagram here. I'll start over. And now I'm going to look for 2 lines that form right angles. So in the diagram, I'm looking for a right angle, which if you remember is indicated by the little kind of square, the little box in the corner. So I can see I have 2 right angles on my diagram. So I have 2 different sets of perpendicular lines. So AB and EF, I'm sorry, AE is one example. Okay, so notice how angle A there is the right angle. So AB and AE are perpendicular. And the symbol for perpendicular lines looks like an upside down capital T. So you can say line AB, perpendicular symbol there, and then line AE. Okay. And then we have another pair. So if you look down here at point G, that is another right angle that we have. So line EG and line GH would be perpendicular. Okay. All right. Skew lines. skew lines, these tend to be the kind of the trickiest because they are neither parallel nor perpendicular. And in fact, they're not intersecting at all. They're on different planes. Okay, so the definition is that they are not coplanar, and skew lines are not parallel and do not intersect. So for example, if we look at line AB, so if we go back up here to AB, a line that is skewed to that can't be on the same plane. So it can't be on the top. It also can't be on this back because line AB is on those two planes at the same time. But it also can't be parallel. So we have to make sure that we pick another line that kind of think about it as going in an opposite direction on a totally different plane. So EG would be an example. If you think about this as a room, right? So imagine yourself standing in this box. That's a room that you're standing in. So if you can kind of imagine, you have AB would be the intersection of one wall and the ceiling, kind of going in one direction, okay, up at the top. And then if you jump to the far other side of the room, you're looking at the intersection of two walls. So it's kind of going up and down. It's got like a horizontal direction and a vertical direction on totally different opposite walls. Okay, that's skew lines. And there's no symbol for skew, so you would just say that line AB and line EG are skew. Okay, another example, just to kind of point that out, let me clear this. Let's just pick, how about down here, we haven't done anything with DH yet, so line, hold on, my little tablet here is off. Let me try that again. All right, so line DH down here at the bottom. And a skew line, you could pick, how about back here, AC. Okay, so see how they're on opposite planes, they're going in opposite directions. So they're never going to intersect because you have all this space in between, and they're not parallel either. So that would be another example of skew lines. And then the last term that we have are parallel planes. So parallel planes are now two planes that do not intersect. And actually it could be more than two, but it's any planes that are not intersecting. So in our diagram, we could think about, you know, the top of this box and the bottom, right? Your floor and ceiling are going to be parallel. Okay, they're never going to intersect. Hopefully your ceiling's not caving in down onto your floor. So that would be one example. Or you could pick, you know, the left and the right. Right, so those two sides would be parallel, okay, or the front and the back. And to name parallel planes, if you remember how we name planes, you just write the word plane and then pick 3 letters of 3 points on that plane that are not collinear. Okay, we've got the parallel symbol again, and then name your second plane. So plane ABE. So this is back up here to the green, the top parallel or the top plane. And then parallel to the bottom plane, CDG. All right. So let's take a look at a kind of a fresh example here, and let's practice naming. So a pair of parallel segments. So take a second and think if you can pick out a pair of parallel segments. So you're looking for matching up with the arrows, okay, 2 lines that are never going to intersect. So I can see one here, KN and LM would be an example. Okay, they've got the single arrow indicating that they're parallel. So I can say segment KN is parallel to segment LM. Okay. Or you could match up another pair. We have PS is parallel to QR. And actually all 4 of those are parallel to each other because they all have the single arrow on them, okay? Or if you wanted to, you could pair up some of these double arrows. So we can go in a different direction here. We could say that, oops, let me get my pen. We could use NS here, and then look to see another segment that has the double arrow. So we actually have 3 to choose from. So how about, let's say, KP? So that would be another pair that we could go with. So NS parallel to KP. Okay, so there's lots of different pairs of parallel segments you could choose. All right, how about skew? Let's keep that line segment up in the front there. Let's keep NS. So now you want to think about another segment that's not parallel, so not one of those other 3 with the double arrows, and not intersecting, not on the same plane. So how about let's hop to the back, and we can go up top here and say KL. That would be a pair of skew segments. So NS and KL. Or NS, and you could go down here and say RQ. That would work. Okay. Right, and a pair of perpendicular segments. So now we're looking for our right angle. So 2 segments that form a right angle. So let's stick with NS again. Notice how at point S we have a right angle with SR. So NS is perpendicular to SR. So there's one example. You also have 2 right angles here indicated at point R, so you could also have put MR and RS are perpendicular, or MR and RQ. And then the last one, a pair of parallel planes. So we're thinking about 2 planes now that are not intersecting. So if we want to again go with kind of the top and the bottom. To name the top, we could call that plane NKL. So pick any 3 points as long as they're not collinear. And the bottom we would call plane, we could say SPQ. So there's an example of parallel planes. All right, now we're getting into some more terms. Now these terms are going to be really important that you really take some time to study them and kind of really get to know what these different types of angles are. So we're looking at a bunch of different pairs of angles, and they're all kind of unique and have specific characteristics. And we're going to be talking about these a lot this chapter. So really make sure that you spend some time studying these. So the first term there is a transversal, which is a line that intersects 2 coplanar lines at 2 different points. So I've enlarged this diagram over here to the left on my screen. So notice here we have 3 different lines, and there's 2 different intersections. So line T is going through line R and then through line S. So T is the transversal, okay? It's intersecting 2 different lines at 2 different points, okay? So then therefore, since you have 2 intersections, you create 8 different angles. 4 of those angles are in the interior, 4 on the exterior. So you can see the colors there. The interior are angles 3, 4, 5, and 6. So the way I like to think of it is, if you were to squish together lines R and S, everything kind of in between there is the interior, okay? Or think of it like a sandwich. If those are your 2 pieces of bread, everything in between in the sandwich, that's all the interior. And then the exterior would be angles 1 and 2 and 7 and 8. So those, think of it as opposite directions of those lines, kind of above and below, or kind of on the outside. Okay, so that's interior, exterior. Now what we can do is we can start to pair together different angles And then we get these 4 different pairs below. So let's just take one at a time. So the first one, corresponding angles. This would be a pair of angles that are on the same side of the transversal and on the same side of line R and S. So let's take a look at example 1. Okay, it is on the left of the transversal, right? So if we think left and right, so it's really important to know our directions here. And then as far as line R and S, we've got above and below, right? We've got 1 is up above line R, 3 is below it, and then same thing down here. We got 5 is above, 7 is below. So angle 1, we can think about it being kind of above line R and to the left of line T. Or think of it as like in the top left position of these 4 angles, right? So then if we go down here to 5, 6, 7, and 8, where is the angle that's in the top left? It's angle 5. So they're both to the left of the transversal, and they're both above line R or line S. So angle 1 and 5 would be a pair of corresponding angles. Okay. There's 3 other pairs of corresponding as well. So it all has to do with position. So if we think about angle 2, it's to the top right. We could think of it that in the top right position, or it's above R and to the right of T. So if we look down here, angle 6 is also in that same position. It's in the top right. So angle 2 and angle 6 are another pair of corresponding angles. And then we have 3 and 7. Okay, they're both at the bottom left, bottom left. Okay, so angle 3 and angle 7. And then 4 and 8. Let's see, I'm running out of colors here. We'll do 4 and 8 would be another pair. Those are both in the bottom right position. Okay, so corresponding angles all has to do with the kind of the location or the position of where the angles are. And they're in the same position. All right, let's move on to alternate interior angles is next. So if you think about the words alternate interior, it's kind of giving you a clue as to what they are. So interior, so we're focused on just 3, 4, 5, or 6. And then alternate means that they're on alternating or opposite sides of the transversal. So there's only 2 pairs of alternating interior. You have 3 and 6 would be 1 because you've got them both in the interior. 3 is on the left, 6 is on the right of the transversal. Okay, or the other pair would be 4 and 5. Okay, 5 is on the left, 4 is on the right. So 3 and 6 is one pair, 4 and 5 is the other pair. All right, then we go to alternate exterior. So kind of the same idea, alternate meaning opposite sides of the transversal, but now we're in the exterior. So we're focused on 1, 2, 7, or 8. So 1 and 8 would be one pair. Okay, angle 1 is on the left, angle 8 is on the right. And then 2 and 7 would be the other pair. Okay, you got angle 2 on the right, angle 7 on the left. So we can add angle 2 and angle 7 to our example. Okay, alternating exterior. And then the last type, last pair, are same side interior. Okay, so we're jumping back to the interior, but now on the same side of the transversal. So there's 2 examples of these types. There's 4 and 6. Okay, they're both on the right side of the transversal. And then 3 and 5 are both on the left. So angle 3 and 5 and angles 4 and 6. Okay, I know that was a lot. But again, just you can rewatch this, just kind of take your time. Look at these examples over when you're done, really review, and just really, again, think about the name of the angles. So a lot of these have clues in the name. There's interior versus exterior. Think about what alternate means versus same side. And it's just a matter of kind of matching up pairs of angles based on the criteria of each one. Okay? All right, let's look at another example. So once you pause this, take a minute, see if you can think of an example of corresponding angles. There's 4 different pairs. Again, you're thinking about the position. Make sure they're in the same spot. So either pick the top left, top right, bottom left, or bottom right. Okay, so one example, we could match up 1 and 5. Okay, those are both in the top left. Or we could say angle 2 and 6. Or 4 and 8. Or what did I not do yet? 3 and 7. Okay, those are our 4 different pairs of corresponding angles. Okay, alternate interior. So focus on just the interior. So 3, 4, 5, and 6. An alternate would be on opposite sides of the transversal. So we could pick 4 and 6. Or the other opposite would be 3 and 5. Okay. Alternate exterior. So now we're jumping to the exterior. So 1, 2, 7, or 8. Alternate still, we're talking about opposite sides of the transversal. So we have angles 1 and 7, or angle 2 and 8. And then same side interior, so we're back to the inside, 3, 4, 5, 6. Same side, so 4 and 5 are both on the left of the transversal. 3 and 6 are both on the right of the transversal. Okay. All right, last example here. Now this one's a little bit different because we have 3 lines, but actually 3 different intersections that are created. So it all depends on which 2 angles that you're matching up to determine which one's the transversal. So the hint there on your note says that to determine which line is the transversal for a given angle pair, you need to locate the line that connects the vertices. Okay, so what does that mean? So we're looking at angle 1 and 5 to start. So we need to figure out what type of angles those are. So notice both of those angles are on line N. Okay, if you connect the 2 vertices, you have line N. Line N is also, it's the line that's creating both of those intersections. So that's the transversal for 1 and 5. And sometimes it's helpful to think about, okay, so interior versus exterior, because that kind of helps narrow it down. So then if you think about like squishing these 2 lines together, L and M, the interior then would be 1, 2, 5, and 6. Okay, those 4 angles. And then the exterior would be the 2 angles above line L, the 2 angles kind of below line N. All right, so 1 and 5. So those are both on the interior, and they're on opposite sides of the transversal, okay, or on alternating sides there of line N. So those are alternating interior. Okay. All right, now 3 and 6. So kind of got to start all over, think about where 3 and 6 identify the transversal. So both 3 and 6 are on line M. Okay, that's the transversal. They both share, their vertices are both on that line M. And they are both in that bottom left spot. So if they're in the same position, so they're on the same side of the transversal, they're both below the line, so line L and line N, those are corresponding. Okay. And then next we have 1 and 4. So we have 1 is here, 4 is there. So line L is the transversal this time. Okay. 1 and 4 are both on the exterior. So sometimes if you'd like to think about your transversal, sometimes it's helpful to always think about it going up and down, and then you have exterior would be like above, below. Feel free to just rotate your paper, turn your head, whatever is helpful for you. Okay. But what you end up having here is, so the interior would be those 4 angles. Okay, the exterior would be where 1 and 4 fall. Okay, and they're on opposite sides of the transversal, so those are alternating exterior. All right, and then our last pair, 2 and 5. So again, let's just kind of start over here, figure out where they are. Okay, the transversal for those 2 angles is line N. Okay, that's the line connecting those 2 angles. And again, if it's helpful, let's think interior versus exterior. So if we look at all the angles in between the 2 lines, 2 and 5 fall in the interior. But this time they're on the same side of the transversal. They're both on the right of line N. So those are same side, interior. Okay, and there we go. So again, I know this is a lot of information, but just kind of go back and really just review, and it's just a matter of kind of studying these terms, because like I said, we're really going to be working a lot with these different types of angles throughout the chapter.